I think if you asked 5 philosophers what they think philosophy is, you'd get 10 answers. For me, philosophy is about asking the foundational and conceptual questions about an area, about a domain, about a set of phenomena. It's asking the questions that we often take for granted in our everyday lives or in our professional lives. So what does that end up looking like in practice? Well, if you're doing, for example, philosophy of science, I think that what that often amounts to is asking the kinds of questions that scientists themselves know they ought to be asking, but they're too busy doing science to stop and ask them.
This is Sachin.
And this is Eric.
Welcome to Luminary, kitchen table style conversations with some of the world's brightest minds exploring boundaries of human knowledge.
Join us on a pursuit to transmit intuition and ideas. Find us at luminary.fm or on Twitter at luminaryfm. We'd love to hear from you. Today's guest is David Danks, professor of philosophy and psychology and head of the Department of Philosophy at Carnegie Mellon University. His research lies at the intersection of philosophy, cognitive science, and machine learning, with a recent focus on the ethics of and policy for autonomous systems such as self-driving vehicles and autonomous warfare. David is the author of Unifying the Mind, Cognitive Representations as Graphical Models, as well as Building Theories, Heuristics and Hypotheses in Science.
In our conversation with David, we cover his journey into philosophy, learning models, causality, the impact of information overload on human cognition, and the role of trust in human technology adoption cycles. David also shares his views on ethics and policy considerations for autonomous systems and how we might think about agency and sovereignty for artificial intelligence-based systems.
Really curious about your childhood, where you grew up, and your journey into academia.
Sure. So I actually grew up in Northeast Ohio in a small college town, Kent, Ohio, and grew up in a really quite remarkably middle-class, boring life. Summers riding bikes around a neighborhood. It was a town of 25,000 people with 20,000 college students. So pretty much everybody in town either worked for the university or worked for somebody who worked for the university. And it made for an environment that, in retrospect, I've realized was incredibly good at just being curious about lots of different things. It wasn't growing up a life of being overscheduled. It was a life of being able to spend a lot of time reading. I was incredibly curious and interested in mathematics in particular, and so really focused on that in a lot of ways. I loved the fact that you could actually figure things out without having to do an experiment in mathematics. That always sort of impressed and astonished me in some ways. And, so had in that sense a fairly, I think in some ways, normal experience growing up, with the exception that my father was at the time, he's still alive, but was a psychologist who collaborated with people around the world. And so I did have the opportunity growing up to very quickly start to understand that other cultures were not like Northeast Ohio. So, for example, when I was 6 years old, we were in Poland while it was under martial law. And so you start to really appreciate that not everyone has exactly the same kind of life you do. Different people approach problems in very different ways. And I think that combined with this sort of just wanting to know everything about everything, enabled me to have somewhat broader horizons growing up in Northeast Ohio than a lot of the people that I grew up with. So graduated high school and said, I'm going to leave this area and don't really want to come back. Now, I now live only 2 hours away from there because of Carnegie Mellon, but really went with this mindset of, if you're just curious about something, then that means it's worth looking into. It means it's worth investigating. Not so much thinking I have to go to college to, have a career, or go to college to get these skills so that I'm employable, but much more the mindset of just be curious and good things will follow.
That's quite fascinating. I guess it also resonates or is demonstrated in your work, where you worked in so many different fields.
I mean, it absolutely is. I feel very lucky that I've been able to make things work where I don't necessarily pay very much attention to disciplinary boundaries. On paper, I look like a traditional philosopher. My undergraduate degree is in philosophy. I have a PhD and went straight to graduate school, got a PhD in philosophy. I now work in a philosophy department. And yet I've had, I think in some ways, one of the most unusual philosophy backgrounds that one could have. I was able as an undergraduate to count math classes towards my philosophy degree because of a particular exception that they had in the rules where I did my undergraduate work. When I did my PhD, an entire chapter was actually experimental psychology because I realized that the work that I was doing in philosophy in that time on causal learning, on how can we humans or a machine or really any agent come to understand the causal structure of the world around it. And at that time, I realized there were some obvious, to me, psychological implications of the philosophical and computational work I was doing. And I couldn't find anyone else to run the experiments. And so I suppose I've never stopped doing the strategy of, well, that seems fun, let's go do that. And so simply took a year in graduate school and did an apprenticeship with a psychologist at UC San Diego, where I was, and learned how to run experiments because, well, that's where the interesting question was. And, that's really something that when I think about the through line of my sort of intellectual journey, the theme that just keeps coming up over and over is looking at a problem and saying, that seems interesting. I guess I'll work on it for a little while. And that's taken me in some unusual directions. It means that I have a somewhat odd background, but it does also mean that I'm now, I think, in a position that I'm able to bring together insights, for example, from psychology and machine learning, and bring those to bear on thinking about the ethics and policy of AI.
You mentioned about interest in a problem. How did you develop interest in these diverse fields?
I wish I knew. I really do. In retrospect, I've figured out that I think that what binds all of these different problems together is that they all focus on the question of how any cognitive agent, whether human, machine, animal, can handle the complexity of the world we live in. We live in a remarkably complicated world, whether physically, socially, in terms of the dynamics over time, and yet we handle it incredibly well. We're able to have conversations that span thousands of miles in real time, as we are right now. We are able to talk to other people in a matter of seconds, come to understand what motivates them and how they think about the world. And we have machines that can actually help us to handle a lot of the complexity, whether it's doing image recognition so that we don't have to look at thousands of pictures, or vehicle assist. Even if we don't have self-driving cars yet, many people now have vehicles where the car is helping them to drive in really important ways that make us all safer. And all of the questions I've been asking have, in retrospect, I've realized, had this theme of how do we manage to just tackle all of this complexity without failing over and over? I mean, we focus on the times when we fail, when we misunderstood somebody, when our plans don't work out. And we tend to miss, I think, all of the times that we do it so incredibly well that it becomes second nature or just expected. So there is that theme. Of course, in the moment, it's always just been a matter of, that seems really interesting. Let's go do that. And not worrying very much about whether it all hung together in some coherent structure.
On a high level, what are the main research problems you're working on today? And in particular, what type of research methods do you use to seek answers to those research problems or questions?
That's a great question, because I think in academia, people often use the research methods of their discipline. But when you have the kind of multidisciplinary, interdisciplinary background and experiences that I've had, you end up not really having any particular preferred set of methods. So I'm lucky enough to be in a position, especially here at Carnegie Mellon, where I use whatever are the right methods to solve a problem. So it means that from day to day, I'll be using the methods of psychology or philosophy or computer science. I run experiments. I don't usually run experiments. Graduate students I work with run experiments these days. I used to write code. Now I collaborate with people who write code. You're noticing a theme here. But also the tools of policy making. So what are the legal and regulatory options available as some new technology gets built? And that starts to now bleed into an answer to your question about what research I'm working on right now. Right now, I would say most of the work I'm doing falls into one of two large bins. One is looking at a range of questions around cognitive science. So in particular, how is it that we humans come to understand the causal structure of the world around us, particularly just by watching the world? So we can see a few billiard balls hit one another and figure out something about the causation of those objects. But also then how, at the other end of the cognitive spectrum, from the low-level perception, how do we use that knowledge to shape and guide the linguistic inferences that we make? So not just how does causal information get in at the front end through our perceptions, but then how does it change the ways that we interpret what other people say? So that's sort of one bucket of work is on the cognitive side. The other, probably bigger one, is around these questions about the ethics and policy of AI and other kinds of autonomous advanced technologies. So, for example, we see more and more that diagnostic AI systems are rapidly spreading, they're rapidly advancing. We now have multiple systems that have proven in controlled experiments to outperform human doctors at diagnosis. And these systems raise a whole host of ethical questions, whether it's about bias and fairness in the errors that they make, because all systems make errors. It's not that they're bad systems, it's just the nature of inference and diagnosis in a noisy world. So are their errors fair and unbiased? How does the introduction of these systems change the healthcare system itself? If your doctor becomes simply an information broker, then they don't necessarily seem to be a trusted partner in your healthcare. And so, does both psychologically and in principle, does the introduction of diagnostic AI systems alter the interpersonal dynamics between patient and doctor? And so these kinds of questions about how do we ensure that the technology that's being created, which has the ability and power to truly change people's lives for the better, how do we ensure that it actually has that impact, as opposed to a lot of the side effects, externalities, and other kinds of problems that, quite frankly, if you just pick up the newspaper these days, there's any number of examples of cases where technology has ended up harming people more than it's been helping people.
What is philosophy?
Wow. I think, so I'll give you my answer to the question. And I preface it that way because I think if you asked 5 philosophers what they think philosophy is, you'd get 10 answers. For me, philosophy is about asking the foundational and conceptual questions about an area, about a domain, about a set of phenomena. So it's asking the questions that we often take for granted in our everyday lives or in our professional lives. So what does that end up looking like in practice? Well, if you're doing, for example, philosophy of science, I think that what that often amounts to is asking the kinds of questions that scientists themselves know they ought to be asking, but they're too busy doing science to stop and ask them. They're the questions about the underlying fundamental assumptions of the scientific practices. Or we can ask ethical questions about what ought we do in order to realize our interests and values in the world. Or political questions in political philosophy, about how we should function as a society in order to ensure that the goals of our society are being met. And these are the kinds of questions that I think most of the time in everyday life we don't think very much about. We just know better, for example, than to steal money from somebody else. We don't think about why is it wrong to steal money from somebody else. Let me be clear. I think it is wrong to steal money from people. But stopping and asking, okay, why? What are the reasons for that belief? Stepping back and questioning the assumptions that we have to make to get through everyday life. The philosopher Friedrich Nietzsche, there are a lot of things he said that I deeply disagree with, but I think one thing that he emphasized quite a lot in his work, which I do agree with, is that everyday life requires that we just make assumptions. It requires that we take so many things for granted. And there's value, and I think what philosophers can bring to the table is the value in stepping back and asking, are we sure that those are the right assumptions? Are we sure that we're thinking about our world in the right way? And then the value, I think, of that is not just in asking those questions, but it's in the habits of thought and the methods and techniques that philosophers have developed, because now we can walk into a field like diagnostic AI systems or self-driving cars and ask about all of the assumptions that are being made in those areas as well. We can help to have the developers, the regulators, the users question their own assumptions to see whether, in fact, what's happening is we're getting the technologies that we want.
So how do you know that the question you're asking is really at the heart of the issue?
Well, as with so many research questions, the problem is exactly that you don't know. This is one of the challenges that I think, for example, a lot of undergraduate and graduate students discover when they first start doing research is if we knew what the answer was, or we knew even what exactly the right question was, it wouldn't necessarily be research anymore. It would be a homework problem in a class. And so there has to be a certain willingness to experiment in this case intellectually, which is take a chance. Say, all right, here's what I think is the right question. Let me pursue that line of inquiry. Let's see where it leads us. Let's see if it leads us to a place where we're getting guidance that we think is going to help us do better, either in our own lives or in our scientific practice or in the development of technology. And then be willing periodically to come back and revisit that assumption that we made. So it's not the idea that we're going to ever know with certainty that we're asking the right question or that we found the right answer, but it's trying to help improve the kinds of questions and answers that we're asking. I know in my own work, I occasionally have looked back at papers that I wrote even just a few years ago, and I sort of roll my eyes that, well, I got the question wrong. I wasn't thinking about it in the right way yet. And it doesn't mean that the paper was wrong. It doesn't mean that it was a bad idea to write that paper or put those ideas out there. It's to say that all inquiry worth doing is risky. It could lead us in the wrong direction. It could lead us down the wrong path. But the alternative, it seems to me, is not worth doing either, which is to simply go with the assumptions we have and never stop to question them.
So both personally and professionally, how has your foundation in philosophy influenced your worldview?
Well, I mean, I think the biggest way it's influenced is exactly that I struggled to take for granted the assumptions that people readily make in other disciplines. So in that sense, I think philosophers sometimes have a quite justified reputation for being a little bit annoying, because we walk in the room and we say, but why? Understandably, I think that, for example, engineers sometimes get annoyed at that. But I think what it does is it has helped me to think about, why do people investigate the questions they do? Why do people try to build the technology that they do? What are the assumptions that they are bringing to the table? And how can we look carefully at those assumptions to see where there might be opportunities or possibilities that we aren't seeing right now? So let me give an example. In the mid-1990s, when I was in graduate school, in the psychological work on causal learning, on these questions of how it is that people learn about the world around them, there were all kinds of assumptions that people were making about the nature of human representations, basically. How do we think about the world? And I think coming from a philosophical background made it easier to ask whether those were the right assumptions. And in particular, I think once I and other people, I was certainly not the only person doing this, once this group of us started asking these questions about whether this was the right assumption about human representation, we pretty quickly realized that it probably wasn't. And so we started looking around saying, well, could we find some other assumption that might be more sensible? And it turned out that actually machine learning, we didn't call it machine learning back then, we called it automated discovery or automated reasoning, but machine learning actually had exactly the assumption that we needed. And so it was only by asking questions about the assumptions in psychology that we were able to see the value of work over in machine learning. And I think that this comes up over and over. It's only by asking about the fundamental assumptions of the ways that we regulate cars in this country that one can start to see where psychology could provide some further insights into ways to better regulate self-driving vehicles to advance people's interests. That this focus on assumptions means that it's more likely, or at least in my case has turned out, I think, to be more likely, that you can see how other disciplines might help, rather than getting stuck in that disciplinary silo.
Speaking about the why, what is the significance of doing research in cognition and learning? Why do that research?
I think the reason that it's valuable, I think there's a lot of reasons. The first, and one that's very important for me personally, is that I think that our abilities to learn and reason about our world, that is, we humans, are in certain ways simply unmatched by any other non-human animal, and even in some cases and some domains, unmatched by our very best machines. And, if we go back to, for example, say Aristotle, we find him arguing that man is the rational animal, that humans are rational animals, that what makes us different from the other animals is that we're rational. We can think, we can reason through and understand our world in a way that other non-human animals just don't seem to be able to do. And so one thing that I think is really valuable about trying to understand human learning and reasoning is that it gives us a window on what's distinctive about us humans. We build societies and communities in ways that no one else does, no other kind of creature that we've encountered does. So what's different about us? I think to ask that kind of question is immediately to be led, among other things, to learning and reasoning. Now, I'm also very interested personally in human learning and reasoning because I'm interested in how we can improve it. And that's not to say that we should always be trying to improve the human mind. I think the human mind is usually a lot better than it gets credit for. But I think it's very important when we think about our learning and reasoning to recognize that we do have failures. We do have blind spots. We are sometimes overly biased. We're subject to what we call motivated reasoning, where things that we want to be true, we think are more likely to be true, even if the evidence doesn't point in that direction. And I think if you want to improve human reasoning, either through teaching people or through the development of technologies that can assist people, or even to see whether there might be cases in which the best thing to do would be to replace the human learning and reasoning with that of another system, basically build an AI that can replace a human in some context. I think to do these things responsibly, one actually needs to understand the target. You need to understand what human learning and reasoning is. And so that's really just led me to focus on these questions of how humans figure out enough about the world to achieve most of our goals.
Yeah, and that leads nicely into this notion of causal learning. So break that down, talk about that. You've thought about that a lot. You published a lot on the topic as well. What is causal learning? How is it different from learning?
Yeah, so the easiest way to think about it is, I think that causal learning is, of course, a kind of learning. What you're learning is you're learning causal knowledge. So what makes something causal knowledge? That's a natural question to ask. And the easiest way I think to think about this is by thinking about diseases and their symptoms. So if I have the flu, I'm going to have a fever. So if you were to see that I have a fever, you can use that information to predict that I probably have the flu. But if you just give me something to get rid of the fever, that doesn't do anything to cure the flu. That might buy some time for my immune system to cure the flu, but you're not directly influencing the underlying cause. You're just treating the symptom. What causal knowledge enables us to do is it enables us to design, plan, and carry out effective actions. Because if you want to act on the world, what you need to be able to do is you need to be able to act on the causes, not the effects. Because if you act on the effects, you're not going to change the world in the way that you want it. So you need to think about what are the things that are actually causing the events that you care about. And that's what you want to try to target with your actions. Now, this emphasis on action, I think, highlights an important way in which causal learning might not actually be something that is needed in all cases. So if all I want to do is predict what the world is going to be like, I don't need to actually have causal knowledge. And you see this, for example, in many modern deep learning systems. So deep learning systems struggle in many ways to learn the causal structure of whatever produces the data that they're learning about. And deep learning systems are fantastic for prediction. They turn out to be much less good, I won't say bad, but they're less good at figuring out actions in the world if they're not able to just do it by trial and error. Of course, one way to figure out how to achieve your goals is to just try a bunch of different things and see what succeeds and what fails. But one of the things that's really striking about humans is that we have the ability to plan effective actions, even when we've never been able to act on the world ourselves. That just from watching the world, we are able to then go out and change the world so that we can achieve the things we want. We can watch the wind shake the branches of the tree and cause an apple to fall to the ground. And then when we want an apple, we can walk over to the tree and shake the branch. And that's something that actually seems to be a mostly distinctive to humans' ability. And it's something that is difficult to get a machine to do, in part because, as the old adage that we all learned in intro statistics tells us, correlation is not causation. Just because two things are correlated or associated or carry information about each other, that doesn't mean that there's any direct causal connection between them. That's like the symptoms and the disease. And what causal knowledge and causal discovery really is all about is how do you go beyond the data? How do you take the sort of surface data of what the world looks like and make inferences, learn about what causes the world to look like that? It's hard to do, but it's absolutely critical if you're the kind of creature or if you're a machine or a robot that's going to be interacting with the world and trying to change it to make it better for you.
In that vein, what are the other forms of learning other than causal learning, and how do they compare and contrast with causal learning?
So, I think we can think about this causal learning. There is learning from instances. So this is the idea that what people or sometimes machines do is that they have a record of past experiences. And when they're in a new experience or a new situation, what they do is they basically think about what past experiences were like this and then assume that the world will be sort of like those past experiences. So you're not trying to learn any underlying structure. You're just assuming that the world is going to be roughly similar to what it was in the past. And as you get more and more instances there, what that kind of learning starts to become is the learning of patterns. So you discover that every time a switch is in one state, the lights are on in the room, or most of the time, maybe the lights are burnt out or something like that. And those kinds of pattern learning, which are what a lot of machine learning systems are very good at, can be particularly powerful if what you're learning is patterns over time. So if you can learn that, oh, whenever these three things happen, this fourth thing happens, then you can start to plan and protect yourself against the possibility of things going wrong. There's also what we sometimes refer to as learning by analogy. So this is the kind of learning in which you recognize that one system is sort of like another one in various respects. So an electrical circuit is sort of like a spring, a ball on the end of a spring bouncing back and forth. The sort of oscillations in the current look like, in some ways, in mathematically precise ways, the movement of this ball at the end of the spring. And that kind of analogical learning and reasoning enables us to transfer the insights that we have in one domain into insights in a sometimes completely different domain. It's interestingly one of the things that humans are still much better at than machines. Analogical learning and reasoning is something that we're still trying to understand how to get machines to do it, partly because we don't really know how humans do it very well. So there are all of these different ways that you can learn about the world around you, and then of course use what it is that you've learned to reach your goals, to manage to find another cup of coffee or find a life partner or whatever it may be.
Right. So would you say that the extent to which assumptions are challenged is a core differentiator with respect to various learning models?
Yes, I think in particular which assumptions they make. So one of the reasons that some people sometimes object to, for example, causal learning as something that we should do in a machine is because typically causal learning systems have to make more assumptions about the world than pattern learning systems that just learn patterns in the data. And in many cases, what you get out is going to be a function of what you put in. And what you put in is not just the data. I think that a lot of people think about that. That's where, we have the saying garbage in, garbage out. That saying the garbage there on the inside, that's data. If you have terrible, noisy, junky data, you're not going to be able to find very much of interest. What we don't talk about as much, I think, in the machine learning community, or at least we don't talk about it outside of machine learning conferences, perhaps, are the assumptions that are equally part of the input side. So if you have great data, but your garbage is in the assumptions, if you make just entirely the wrong assumptions about your system, then what's going to come out at the other end is also going to be terrible. So if I've got incredibly clean data about a nonlinear system, and I assume that it's actually linear, the points could be plotted essentially on a straight line, then I'm going to get a terrible model at the other end because the assumptions don't fit the way the world actually is. And so I think that this notion of looking at the assumptions, of carefully thinking about which assumptions are justified for a particular problem, for a particular data set, for a particular goal, is absolutely critical to successful cognition by people, but also to successful machine learning and successful AI. I think ultimately it's something that most people who are good at AI and machine learning do almost without thinking about it. And in the sense of the do there is that they're looking to ask what assumptions are justified in this domain and which ones aren't. And it's precisely because they do it without thinking about it. They do it without necessarily openly talking in papers about how they decided which assumptions were legitimate or defensible, that sometimes you get this perception by people that things like AI are simply these magic boxes that can learn no matter what. Similarly with humans, we make assumptions when we interact with the world, and sometimes those assumptions are violated, and that's what we call illusions. So optical illusions occur because there are sort of assumptions that your visual system makes, and when those assumptions are violated, you learn something false about the world. Similarly, there are causal illusions. I can give you a scenario where you will think one thing causes another, but actually it's just an illusion. And it's because I'm taking advantage of the assumptions that are built into the ways that you learn about the world.
How would you define causality?
So I tend to be a pragmatist about this, in the sense that I think that causality is largely this idea that if you could change the state of the cause, the effect would probabilistically change afterwards. Okay. Now I've said that in this very, unusual what we call counterfactual language. It's not about you actually having the ability to change the thing. We don't have the ability to change the location of the moon in order to see whether if we changed it, gravity would change. We just don't, we don't have that technological capability. And so instead, it's the idea that if there were something that changed the state of the cause, that change would in some sense flow downstream to the effect. Now, I cheated there, because I just described or gave a kind of pseudo definition of causality using the word flow and downstream, which are, of course, causal notions. And I think one of the challenges that we have when we work in causation is that we can give these kinds of pragmatic or functional definitions of it, but it's very hard to go beyond that. Now, personally, that doesn't bother me very much. And it doesn't bother me because the work that I've done in cognitive science has led me to the conclusion that causation and causal reasoning and causal perception and understanding of the world are simply part of the bedrock nature of our cognition. It's sort of like trying to define time or space. They are so much a part of how we understand the world that it can actually be very difficult to disentangle that concept from all of the other foundational concepts. So I think it is actually very hard to separate our concepts of agency, of things that do stuff in the world, from our concept of causation. And so that makes it hard to give a very precise definition that doesn't sort of have these more functional characteristics. Because I think that ultimately when we try to define causation, or at least define causation as it is for us humans, we ultimately aren't able to open up the box of that concept and look inside of it. And so we have to fall back on, well, how do we use it? What role does it play in our cognition? What are the inferences that we consistently, systematically make when we think we understand the causal structure of the world?
The way you're speaking about causality comes across as a binary thing. Would you say it's a binary thing, or is it more of a spectrum?
Well, I think in general, the world, of course, is a messy, complicated place. That's where we started much of this. But I think that we can usefully think about causation as happening or not. And if there is a causal relation, we can think about the strength or the degree of the causal relation. So there are some things where there just isn't a causal connection between them. Equally, there are cases where there's a causal connection, but it's so weak that we might as well treat it as not present. Now, we don't always know which cases are of the former sort, there's no causal relation, and which are of the latter sort, it's just a weak relation. And that can matter. That's the whole idea of something like the butterfly effect, where something that we think is a very weak, to the point of being non-existent cause, actually can have these very large ramifications over time. But in general, I think there's a lot of evidence that we humans do represent causation both qualitatively. Does this thing matter for that one or not? And then among the things where we think there's a causal relation, we do have some understanding of the strength of causality or causal interactions where, the lights are on in my office only if the switch is in the right position and there's power to the building. So kind of interactive cause where more than one thing is needed. And so I was falling back into the sort of binary language, and that's definitely a good point to make, is that while that seems to be, I would argue, a kind of first pass for how we think about the world, which is sensible because we want to be able to quickly detect what's relevant and what's not, we then supplement that kind of understanding of the binary qualitative relevance relations in the world. We supplement that with information about the strength of the causality or the nature of the causality. This one works by physical contact, for example.
In the world we live in, there's a lot of data, if you will. I guess one can say there is information one can derive from that data, there is misinformation, and the rate at which this is being propagated or spread around is pretty fast. We are all connected. What is the impact of, I guess, this information overload on human cognition and decision making?
Mostly negative, as we're all seeing. So one of the problems that we're encountering, I think, more and more frequently, is that it turns out that humans are good but not great at searching for information, which makes sense if you just think about the kinds of environments that we've usually lived in historically. So we're not terrible at finding information, but we're not good enough at it to handle an environment, a setting in which there is, as you said, information overload. And in particular, when we look at people's tactics and responses to information overload, we see that one response is, of course, just to ignore large amounts of information. But people are not very good at knowing what to ignore, and so they miss a lot of important information. They focus on irrelevant things. The other strategy that people pursue is actually looking to their social networks, that we have over and over a kind of division of cognitive labor. People are used to the idea of a division of physical labor. For example, in an assembly line in a manufacturing plant, different people will do different physical jobs to create a car, for example. There's a similar related idea of a division of cognitive labor, where you trust that other people have done the hard thinking to learn about, to understand, and to be able to fix or respond to various kinds of challenges. And in particular, that those other people can act as an information source. So personally, I find, for example, when I have questions, I often don't any longer go onto the internet. I will often reach out to people in my social or professional network to ask them because they know more about it than I do. And I am trusting those people that they actually are telling me the right answers, or they're at least giving me a good understanding of what matters and what doesn't. So in the face of information overload, sometimes the right thing to do is to look to people. The problem, I think, that we often have nowadays is that it's becoming harder and harder to know who actually is an expert in something. Who's actually somebody that when we divide up the cognitive labor, we're comfortable giving that task to that person. On the physical labor side, you would not want to give some complicated mechanical task to me because I'm a klutz. I'm not just a pretty clumsy person. And so we understand in the division of physical labor, you want to give people the tasks that they're able to do, and we know how to identify who can do which task. We don't know how to do that when it comes to the cognitive labor side very well. I don't think that the modern information economy is set up to help people identify who the experts are. So whether you pursue the strategy of just ignoring lots of information, or you try and be responsible and you try and find experts, you try to find the right people to talk to. In either case, I think what we find in modern society is that people are not able to get reliable access to the right information for what they're trying to learn and do. And so we see all of these cases, I think, now where there are things that people refer to as cognitive failures, or where somebody will say, people just don't think very well today, or why is there such a failure of critical thinking when it comes to engagement with science or politics? And I think in many cases, it's actually not a failure of critical thinking. It's a failure of people to be able to get access to the right kinds of information, because they are, as you said, just overwhelmed and overloaded with information. And we, whether it's we as academics, we as technology developers, have not given people the tools to help them figure out what information is actually going to be helpful or valuable for them.
What is the relationship between humans and technology?
Ever changing, I think, would be the easy answer. So I think the first thing for us to remember is that we still, with very few exceptions, we still build the technology. We still make decisions about which technologies we think are important, which ones we want to construct. Technology is not some hurricane that's bearing down on us, where all we can do is just crouch down and wait for it to pass over. People, humans, folks such as you, very much build these technologies and are making the decisions about what we want the technology to do. So that's what leads me to be hopeful that we can move from our current situation, where I think that there is a significant degree of alienation between people and technology, towards a place that people better see how to use technology to advance their values, their interests, their goals. And what I mean by that is that I think right now, technology is often handed to people where they don't necessarily know how it works. They don't know what exactly it does. And they might even be given misleading information about what it does or what it's supposed to do, because it gets framed as a voice assistant when in fact it doesn't have the capabilities that a human administrative assistant would have, for example. Right now, the challenge we have is that people don't have access to, and even if they had access to this information, they wouldn't know what to do with it, information about how technology works and how they can get technology to work for their benefit. Right now, instead, I think it is often sort of just put out there in the world with the expectation or the hope that people will find good uses for it. And I think what happens in many of those cases is that for quite reasonable reasons, people start out trusting a technology. They start out thinking, it's probably going to work, otherwise it wouldn't be on the market or wouldn't have been made available. So there's an initial period where they will often trust the technology more than they ought to. And so they are then unfortunately surprised or disappointed or even harmed when the technology doesn't live up to that trust, when it isn't able to protect their values, to act on their behalf as if they were doing it themselves, which is sort of a core aspect of trust in technology. And so then we see a very sudden shift where they lose trust. And you get this rapid cycling, both within a person and across a group in a society, between overtrust or large amounts of trust in technology and rejection of technology, the lack of trust, perhaps even active distrust, where people start to sound like a Luddite. They start to sound like somebody who says, I just don't want any technology at all in my life. I present this, admittedly, somewhat bleak picture, in part, though, because I think there are things that we can do to remedy it. I think that there are ways that developers, regulators, marketers, ordinary citizens, educators can all work to improve people's relationship to technology so that they better understand what it can and cannot do, how it can and cannot advance their particular values, so that they're using it in a productive way. And part of the reason I think this is because we actually have any number of historical examples. Whether you want to think of something as simple as a hammer, people have largely figured out how to use hammers and when it's appropriate to use them and when it's not. Or spell check. Most of us have probably gotten very used to the idea that spell check is a valuable, useful technology. I'm very thankful for it. But I also know when I shouldn't trust it. When I'm writing somebody's name, I don't trust spell check because I know that names are often not the kinds of things that spell check is good at. So we know when it works and when it doesn't. We know what its capabilities are and what those capabilities are not. And that process of building appropriate trust in a technology is, I think, a way for us to have a much better relationship to technology than most of us, unfortunately, have right now.
But speaking of technology adoption and that relationship between human beings and technology, how do you think the relationship between human beings and this quite novel technology of artificial intelligence will evolve? What do you think are sort of core tensions?
So I think that the most important, biggest tension is the tension between the use of AI, machine learning, robotics to augment or assist people versus using it to replace people. And that distinction is not always an easy one to draw. Spell check, of course, in a certain sense has replaced people, and we don't think that's a bad thing. So it isn't just automatically that replacement is a bad thing. But what we need to be thinking about is we need to be thinking about which cognitive functions we want to have the AI system help with, perhaps even to the point of taking it over. We're not used to, I think, considering the ways in which our everyday lives break up into smaller cognitive tasks. We are sometimes used to thinking about that in terms of the physical tasks we do. You can think about walking from home to the office or pulling a computer out of a bag as distinct physical tasks. We're not as good about thinking about how our cognitive tasks divide up, all the different things we do over the course of a day mentally. But we need to start thinking this way in order to think about where AI, machine learning, and other kinds of autonomous technologies might be able to help improve some of those cognitive tasks, or perhaps even replace the ones that we don't actually care about. So I think that's really the single biggest tension when we think about the relationship between humans and machines, is are we going to build these machines in order to replace the things that we humans do? Or are we going to build them to try to improve, augment, advance the things that we humans do? And you see this tension playing out right now in many economic arenas, where you're seeing machines brought in to not improve the productivity of workers in a company, but replace workers in a company. And I think a lot of the economic challenges that we're facing right now because of technology are in part because the focus has been almost entirely on replacing people rather than augmenting them or giving them more capabilities. We see this when it comes to things like social media, where you have not as much AI, but you have machine learning that is guiding, for example, what shows up in a Facebook news feed. And that's a case where a cognitive operation, that search for new news, search for content and information that is relevant to me, that has now been replaced by the operations of the machine learning system. Rather than finding ways to have it be an augmentation of my information search. And so I really think that that's at the core of how we interact with the technology, whether it's an augmentation or a replacement. And the problem is that the technology in some sense doesn't care, right? This isn't something where the technology dictates it has to be an augmentation or it has to be a replacement. The technology can be designed almost always in either way. The question about how we want to relate to technology is really a psychological, social, and ethical one. In some cases, as with spell check, it's great to have replacement. That's a really good thing. In other cases, take the well-known example of autopilots. Autopilots in airplanes can do an excellent job of landing airplanes, but we still require humans to do the landings almost always because we think it's important that they keep practicing it and they keep those skills. We don't want to replace humans because we think that the risk of failure would be too high, would be too significant. And so when we think about the relationship between humans and AIs, I think it's really hard to predict because it's hard to know whether developers, whether consumers, whether regulators are going to advocate for what I think we should be doing, which is a relationship of engagement between humans and technology, partnership, teaming, whatever term one wants to use, but where we think about the sort of human technology collective rather than technology as replacing humans, where it becomes adversarial. Because right now we're in a very adversarial setting, I think, in general, when we think about AI, machine learning, and humans. We think of it as an either or, rather than systematically as a community thinking about it in terms of and. How could we get the best of both worlds?
If you would take a historical perspective on this and compare this technology adoption cycle of artificial intelligence to something that happened previously in the history of this planet, what would you compare it to? What might be equivalent in terms of magnitude?
Well, I mean, in terms of magnitude, I think that the natural place to look would be the development of steam and internal combustion engines. That was really transformative in terms of a general purpose technology to convert human physical labor into machine labor. And I think what we see with AI, machine learning, planning systems, computer vision, is we're seeing similarly a general purpose technology that is a sort of engine for converting human cognitive labor into machine labor. So we're not converting physical labor, we're converting our cognitive labor. And it isn't domain specific. I mean, essentially the exact same machine learning systems can be used to build a diagnostic AI, to be able to build a system that can determine whether widgets in some factory are defective, to classify asteroids as a threat to the Earth. I mean, it's basically all the same technology. And so in magnitude, I think this idea of a general purpose technology to convert labor from humans to machines, I really think that's where engines, steam engine, internal combustion, that's the appropriate historical analog. Now, I do think there's a really important difference, which is we are talking about cognitive labor and not physical labor. And cognition is, as we talked about earlier, I think is something that we've often thought was a really distinctive aspect of humanity. So I think that's part of why people feel threatened by things like AI. It isn't just the chance that you might lose a job. It's also that it feels like AI is starting to go after one of the things that seems to be distinctive to us as humans. When a farmer doesn't necessarily mind when they can use a tractor to plow their field instead of having to do it by hand or by walking behind oxen. They're actually probably happy about that in many cases because farming is incredibly hard physical labor. I would really object, and it would go to my sense of who I am if there were a machine that could take over the cognitive labor of research, of philosophical research. If suddenly it was, oh, we don't need you to be here anymore. You've got this AI system that'll do all of your philosophical research for you. Unlike the farmer, I don't want to give up that cognitive labor. That's part of sort of who I am. And so, I think that is part of the reason that it's hard sometimes to find historical antecedents for what we're experiencing in this moment. Because we haven't previously had technological innovations. We've had remarkably few technological innovations that actually touched cognitive labor, that actually touched some of the things that really get at our personal identity, at who we feel like, what we feel like makes us who we are in a pretty deep way. And so I think that makes it really hard to find the right example historically for the kinds of changes, though there are for the magnitudes.
What are then the important design considerations for someone who is building these technologies and introducing them to the masses?
Well, so I think the first design consideration is to think about, for whom are you building? Are you building for advertisers who are going to use a platform? Are you building for the end user who's going to buy a product? And thinking about for those people, for the people that are the target of the design, that are the audience of the design, how do you ensure that what you're building is advancing their interests and their values? And that's a fundamental design question that just requires you to think about what is it that people want. That's not distinctive to AI. Let me make sure to be clear. I mean, that's just a sort of fundamental tenet of good design is figure out what people actually want and what they actually care about so that you can try to give it to them. Now, that might be trickier because it's a little bit harder for us to figure out cognitively what we always care about, but it's very much doable. There are techniques like cognitive task analysis where you can start to get at this. Now, I think there's a second issue that comes up that is highlighted by this way of thinking, which is how do we communicate the target of the design to the general public? So, there have been many people who've pointed out that, for example, the users of Facebook, the people on the Facebook platform, they think it's designed for them, but there are many, many ways in which it's actually designed for advertisers. That the people that Facebook is really designing for are advertisers, and they design for their users only in as much as they want to keep the users on the platform, so they have to do some nice things for them. Now, in fairness to Facebook, I think that that's an overstated description. I do think that there are many people at Facebook that care quite deeply about designing for the users, not just advertisers. But that highlights the fact that it can sometimes be quite difficult to figure out who a technology is designed for. I think that we have a tendency to assume, if we're an end user, that the technology is designed for us. But that's actually often not the case. So I do think that there's this second issue, which isn't necessarily about the design of the technology, but it's about the design of our regulatory and marketing ecosystems, which is how do we help people understand for whom and for what some technology is actually designed? Because I think that can be very difficult to find out.
How are things like ethics, trust, policy play role in design?
Right. Well, so one thing is that I would argue that generally speaking, it's the case that good design and ethical design are remarkably similar. Because good design is, as we were just talking about, it's about thinking about the needs, the interests, the values of the person for whom you're designing. Perhaps the user, hopefully the user. Ethical design is about thinking about the needs, the values, the interests of the person who's going to be impacted by the technology. So good design and ethical design can come apart when people are impacted by the technology, even though they're not the target for the technology. But in many cases, they're going to end up going along together. And what this is really all about is asking a set of questions around how the technology advances some people's interests and values, how it might harm other people, and trying to balance these in sensible ways. So ethics sometimes is thought of as this really highbrow, abstract sort of domain of inquiry or discipline. I think that's just fundamentally not right. I think ethics is actually a very, very practical discipline. Every one of us is an ethicist. We are all ethicists in our everyday life. And the reason that we're all ethicists is because we have values that conflict with one another. So I might want to always follow the speed limit when I'm driving around, but I might also think it's very important that I show up for my meetings on time. And sometimes those values are going to come into conflict. I'm going to have to decide, am I willing to speed in order to get to my meeting on time, or is my value of following the speed limit more important than the value of showing up on time? And ethics is really fundamentally about what ought we do to realize our values, especially when they come into conflict with one another. And that's ultimately at the heart of well-designed technology, is finding resolutions to these kinds of trade-offs, these kinds of different constraints that shape what is and isn't feasible with the technology. And so I think in that respect, technology developers, they're already being ethicists in the designs that they are doing, in the technology that they build. Ethics is already there because they're having to already engage with trade-offs. They're having to build a machine learning system that optimizes for performance along some dimension, what we call loss function. Well, why that loss function? Why that performance optimization? That's an ethical decision to say that these are the things that ultimately matter. And so ethics is already present in design. What we need to do is we need to recognize that we're making these kinds of trade-offs, acknowledge that it's unfortunate that we have to make trade-offs, but it's inevitable, and then be deliberate and thoughtful about which trade-offs we're willing to make. And I think if we can do that, or at least do a better job of that as a development community, as a deployment community through our regulatory practices, I think that's a great way to then build the right kinds of trust in the technology. Because now people are going to be able to figure out, or they will be told, or they will learn, what are the values that this technology is really embodying? What are the values that this technology is going to help to advance? Is it going to prioritize always showing up at meetings on time, even if that means it drives a little bit faster than the speed limit? It's a self-driving car. Or does it always prioritize driving the speed limit? In which case I might decide, well, I guess I just can't use this vehicle at this time because it's not advancing the value that matters to me if I'm running late and it's really important that I show up to the meeting on time or something. It's a little bit of a contrived example, but the point is that it hopefully helps people to see that it isn't that we have ethical design or not ethical design. All design has an ethical component. All development has an ethical component. There's ethics throughout the design, development, implementation, deployment pipeline. It's at every step. What we need to be doing, I think, is bringing it to the surface so that we're making intelligent, deliberate choices about how to resolve the inevitable trade-offs.
Really curious about superimposing this example that you gave of making an ethical trade-off between speeding and being late. So let's take that example and superimpose it to a system that is autonomous, for example, a self-driving car or autonomous warfare. The incidence of that decision is with you, right? If you want to speed or come late. Now, what happens to the incidence of that decision in an autonomous system or an AI-based system? How do you think about that tension?
So I think that if systems are going to be able to act truly autonomously, then they're going to have to be able to resolve these kinds of trade-offs. I mean, if we want to make it even more realistic, it turns out that the speed at which you minimize the probability of an accident when you're driving is slightly slower than the speed of the traffic around you. And so if everybody else is speeding quite a lot, then the trade-off is between minimizing the probability of an accident, which would mean speeding, going not quite as fast as everyone else, but still exceeding the speed limit, or following the speed limit itself. And so that's a case where you don't even need to have a human in the car. For a self-driving car, it simply has to be coded to either follow the speed of prevailing traffic or follow the speed limit or something in between. And that's a decision that has to be made by the developers if the car is going to be able to drive even a block without a human in control. Now, I think an interesting question is, if we start with that particular instance, now suppose I get in the car. Are we going to allow there to be essentially a knob where I can tune how much I personally, as a passenger, prioritize minimizing the likelihood of an accident versus following the speed limit? Are we going to allow that, or are we going to mandate it? And I think that that's actually exactly the sort of question that right now regulators in the US and in other countries are trying to get a handle on. Is with self-driving cars, I think there's coming to be a recognition that these systems have to implement certain kinds of trade-offs. And so asking the question of how much control should we leave in the hands of, for example, passengers about how that trade-off gets resolved? Or should we simply say, nope, we're not going to give people the ability to make those kinds of decisions and instead leave all of the trade-off with the machine? My own view is that a measure of customization, a measure of personalization to people is not a bad idea, but that we need to be very careful about what are the ranges within which we allow that sort of customization. And I think this all goes doubly or triply when we think about the case of autonomous weapons or more broadly sort of militarized or weaponized AI systems. Because there I think it becomes absolutely crucial that we create technologies that the commanders can appropriately trust to carry out what in military circles is referred to as the commander's intent. And of course, that doesn't mean that the commander has to specify absolutely every single thing that the autonomous or semi-autonomous weapon system would do. that would be, of course, to defeat the whole point of having a system that can function semi-autonomously. But what we do need to have is we need to think about what it means for a commander to have a particular intent, what kinds of goals they might reasonably be able to specify for the autonomous system, and then appropriately trust that it could carry out those goals. Now, personally, I'm pretty pessimistic about the possibility that we're going to be able to specify interesting goals. I think in the case of warfare, in combat, we're dealing with environments and situations that are so incredibly complicated and change so rapidly because of the adversarial nature of the interactions that I think that we are a long way off from having systems that can function autonomously within that sort of incredibly complicated environment. I mean, it's sort of the worst case scenario for an AI system.
We have this new paradigm upon us with AI-based agents, if you will. What happens to agency, the notions of agency and sovereignty in that new paradigm? Can AI-based agents be sovereign? What type of agency should they have? Could they have?
So that, yeah, I mean, let me answer from a philosophical perspective rather than a legal one, because I won't pretend to really understand some of the legal implications. I think one of the challenges that we have is that we think of agency in relatively binary terms. But much as you rightly pointed out that we shouldn't necessarily think of causation in binary terms, we really shouldn't think about agency or autonomy in binary terms either. There are many different components to agency and autonomy, and you can have more and less of these different components. And so we really, I think the first step is we need to start to become more comfortable with the idea that agency is not a yes-no question. You can have systems that are more and less agental, more and less autonomous. And that what we're going to see is we're going to see gradually that AI systems move along that spectrum as they acquire more capabilities and they become more and more like true, real agents. How much we give them is, I think, actually a question we should be, and some people are, starting to talk about openly. That maybe we would look and say there's levels of agency that we're just not comfortable building into our autonomous technologies right now. And, clearly we have the ability to constrain at least many AI systems. AlphaZero is amazing at playing Go, but it's not able to just decide that it wants to copy itself onto a new computer system. We've denied it certain kinds of capabilities, or DeepMind has. And so I think we need to move towards a more sophisticated discussion about the nature of agency, what matters to us for agency, and what are we willing to accord or provide to these systems.
What motivates you?
What motivates me? What motivates me is really two different things. One is the completely selfish desire to get to think about and work on really interesting, hard questions and problems. I'll be honest, part of what motivates me is just that I think this is incredibly fun to think about all of these different issues, whether about cognitive science or philosophy or AI and machine learning. The other motivation, though, is that I think these things matter. Our understanding of our own cognition matters. Our understanding of the technologies around us matters. The ways that we are able to advance our lives or not because of technology or because of other people, all of these things matter deeply. And I feel that I have actually a moral obligation as somebody who has the great privilege to be in academia to try to make things just a little bit better, to try to help us understand our world a bit better, to understand our technology, and to move us just a tiny little bit, because I recognize how little I can actually do, move us just a little tiny bit closer to a world in which our values and interests are advanced through technology rather than being harmed by them.
How do you allocate your time?
I would say that I allocate my time around which questions are most pressing at the moment. And questions are pressing for lots of reasons. Sometimes they're pressing because there's a conference coming up, or I've committed to write something for somebody, or they're just psychologically pressing. I can't stop thinking about them in the moment. Right now, for me, that's questions around what are called deep fakes and synthetic media. That's just something I keep thinking about, the ethical challenges of those. Sometimes it's students. I'm lucky enough to be able to work with a great number of really talented undergraduate and graduate students, both here at Carnegie Mellon and elsewhere. And, they are passionate, they are filled with ideas. And sometimes I spend my time thinking about what they are excited about, because that is really inspiring to me to get to see where they go. And of course, as with any job, there are lots of other duties. For example, I'm the head of the Department of Philosophy here at Carnegie Mellon, and so I have to do some administrative work every once in a while.
Which non-consensus views do you hold near and dear?
That's a really good question. I think that the non-consensus view that I hold dearest, that is really not in fitting with the way most people are thinking about it, is that I actually think that the most important property or feature that any technology can have is that we can appropriately trust it. I think all of these ideas that we want explainable AI, or we want transparent AI, or we want predictable AI, or we want reliable AI, or we want white box or interpretable, intelligent, just go on and on. We want efficient, we want effective, we want cost savings AI. All of these desiderata, these things we want from our AI, I think ultimately all of them are just ways of getting us to technology that we can appropriately trust. That there really is just this one thing that is the thing that matters the most to us. And all of these other criteria and features, they're just convenient ways to get to the thing that really matters to us. And that's a very unusual view that makes the human primary in a way that I think a lot of people who build technology, they get a little bit hesitant to endorse.
Yeah, that's really good. What's the biggest trade-off in your professional existence?
There's not nearly enough time to think about all of the really hard, interesting questions. The biggest trade-off simply is there's so many fascinating questions that we just don't know the answer to, and so many amazing people to collaborate with, to talk to argue with, that there's just never enough time in the day to tackle all of the things that are exciting and interesting.
What are you currently reading?
So I'm currently reading a number of white papers and policy memos around the issue of disinformation and hate speech and these kinds of things. I've become very concerned, as have many people, especially here in the United States, about the impact of disinformation and these kinds of technologies, bots, trolls, on our political system. And I've realized that I need to much better understand the psychology and the technology around all of these things. And so I confess it's a little bit boring, but I've been spending a lot of time just trying to wrap my head around this whole giant problem.
What projects are you currently working on?
Well, so one of the big projects is exactly this question about the ethical and policy status of what we call synthetic media, basically being able to make up media. Another problem that is really occupying my time quite a lot is how can we help developers at various AI and robotics companies? How can we help them quickly figure out that a challenge that they face has an ethical dimension? Because sometimes there isn't an ethical question about something you're doing as a developer. If you're trying to decide whether a button should be blue or green, there's probably nothing ethically meaningful about that decision. But what we want, I think, is we want to have our developers recognize when there is something ethically fraught or ethically important about a decision that they're about to make in their development pipeline. Even though we realize that we're not going to train a bunch of computer scientists to be professional ethicists. Instead, what we want is we want to be able to train professional computer scientists to collaborate with ethicists, to know when to call an ethicist. And so while the initial impetus has been to focus on how you could do this in companies and in industry environments, I'm also working to bring this back to the undergraduate and graduate curricula in terms of how we teach students. So when we teach computer scientists, can we teach them how to collaborate with ethicists, how to collaborate with designers or sociologists or economists, even though we realize that they aren't going to necessarily have those skills themselves. So, working on a number of different things.
Yeah, promoting multidisciplinary learning, if you will.
Yeah, and figuring out how to do it right so that people don't have to spend 25 years wandering all around to a bunch of different disciplines just to be able to do it.
How can listeners find out more about your work?
Well, so interestingly, for somebody who works on technology, I am actually essentially not on any social media. So people are not able to follow me on Twitter because I'm not on Twitter. I think I have a Facebook account, but I don't recall the last time I looked at it.
That's contrarian.
It is contrarian. It's the same reason I don't keep potato chips in my house. I wouldn't be able to stop myself. And so I came to the decision about 5 years ago that social media was not helping to advance my values and my goals. And so made the personal decision that I was just not going to be on any of it. It's come at some cost. I mean, I recognize that I have lost some opportunities undoubtedly because I'm not on social media. But in net, I feel good with the decision. I feel like it's worked out well for me. So the easiest thing to do would be I have a web page where I post sort of all of the papers that I'm working on. Thankfully, I have a somewhat unusual name, David Danks, and so I'm the only one at Carnegie Mellon, and in fact, I'm pretty much the only one in academia right now. So it's pretty easy to find copies of my papers, and I also try to be as responsive as possible whenever people have questions.
We hope you enjoyed the conversation. For more information and latest updates, visit us at luminary.fm or follow us on Twitter at luminaryfm. Please subscribe to the podcast, pop us an iTunes review, and share with friends. Don't forget to check out the show notes. And a quick disclaimer, the views and opinions expressed in this episode by the hosts and the participants are solely those in independent capacity and do not in any way represent the views from any organization, company, or management they may be associated with. And thank you for listening.